Hi friends, today I am before you to discuss the topic redox reactions. What is a redox reaction? There is the term that is reduction and oxidation. There is a combination of reduction and oxidation reactions. So let us start with the different concepts of oxidation and reduction. So what do you mean by oxidation? What do you mean by reduction? How we can analyze oxidation is there, reduction is there. So let us start with these concepts. So I am writing the concept of oxidation here and reduction here. Just look. So let us discuss some examples also. So oxidation is nothing but that is addition of oxygen to a species. So addition of oxygen is oxidation. What about reduction? That is nothing but that is addition of hydrogen to a species. So next one, oxidation is addition of electronegative atom to a species. At the same time, reduction is addition of electropositive atom to a species. Let us consider oxidation again. That is removal of hydrogen. At the same time, reduction, removal of oxygen. And from here, that is removal of electropositive atom from a species. And here, removal of electronegative atom from a species. That is the reactivity concept of oxidation and reduction. So next one, some other important concepts are there that are, so oxidation here and reduction here. So the one electronic concept is there. Oxidation is nothing but that is losing of electrons from a species. That is oxidation. And reduction is gaining of electron by a species. Next, one important other concept is that increase in oxidation number during a reaction is oxidation. So what about reduction? Yes, that is decrease in oxidation number during a reaction. And finally, one more concept is there that is very helpful to identify oxidation and reduction reactions. That is decrease in electron density during a combination, and reduction increase in electron density during a combination reaction. That is the different concepts of oxidation and reduction. In summary, we can conclude the concepts of oxidation and reduction as oxidation is the addition of oxygen, addition of electronegative atom, removal of hydrogen, removal of electropositive atom, losing of electrons, increase in oxidation number, and decrease in electron density. Reduction is the addition of hydrogen, addition of electropositive atom, removal of oxygen, removal of electronegative atom, and gaining of electron, decrease in electrons, decrease in oxidation number, and increase in electron density. So let us take some of the examples for this oxidation and reduction. Look here, I am writing one example, that is sodium plus oxygen gives Na2O, sodium oxide. This is a reaction. So we know that here sodium is in its metallic state and oxygen is in its elemental state, and we get the compound here. In this compound, sodium is in its positive state that is that releases electron, and oxygen is in its negative state, that is oxygen accept electron, is it? So this is the state actually. So we can write like this, Na plus and O2 minus. So look here, oxygen is added to sodium, is this? Yes, in this reaction oxygen is added to sodium, so sodium get oxidized. So this is oxidation, and reversibly we can say that an electropositive atom, that is sodium, is added to oxygen, that is electropositive atom is added to oxygen, that is reduction. So that is the concept. In any reaction we can find this addition of oxygen, addition of hydrogen, removal of oxygen, removal of hydrogen and all. Like that we can also find the losing of electrons and gaining of electron. So sodium in its atomic state to ionic state, that loses one electron, so sodium get oxidized, that is sodium loses electron, and oxygen gains two electron and becomes O2 minus, so oxygen gains electron, that is reduction. So in other ways we can count the oxidation numbers. Here the oxidation number of sodium is 0 and oxidation number of oxygen also 0 in its elemental state, and sodium, its oxidation number increased to +1, and its the oxidation number of oxygen is decreased to -2. So increase in oxidation number, that is sodium, and decrease in oxidation number oxygen. So sodium get oxidized and this is reduced. This is the concept related to oxidation and reduction. Let us consider two terms, that is oxidizing agent and reducing agent. Let us take one example, that is H2 plus O2 gives H2O. So half O2. So we know that here hydrogen converted to water and oxygen also converted to water. So let us find oxygen is added to hydrogen and hydrogen is added to oxygen. So the species where the oxygen is added is oxidized and hydrogen added is reduced. So hydrogen is oxidized and oxygen is reduced. So this is reduction. Or otherwise we can find that is by oxidation number or electronic concepts. Look here, this is oxidation number concept, here 0 state, here also 0 state, hydrogen +1 state and oxygen 2 minus state. So the oxidation number of hydrogen increases, so that is oxidation, and the oxidation number of oxygen decreases, that is reduction. So let us consider oxidizing agent and reducing agents. So those get oxidized is due to the reduction of oxygen, is it? So actually oxygen helps hydrogen to oxidize, and reversibly hydrogen helps oxygen to reduce. So those species that get reduced is oxidizing agent. So oxygen here oxidizing agent because that get reduced, and hydrogen is here reducing agent because that get oxidized. So those species that get oxidized is reducing agent and those reduced is oxidizing agent. So you can say the concepts related to this oxidizing agent and reducing agent. How? That is very easy. We know the concepts of oxidation and reduction. The concept of oxidation is matching for reducing agent, and the concept of reduction matching to the oxidizing agent. So let us say some of the concept of reducing agent. Just to say the concept of oxidation, that is addition of oxygen is oxidation, so that is reducing agent. Addition of electronegative atom is oxidation and that is reducing agent. Removal of hydrogen, that is oxidation and that is reducing agent. Removal of electropositive atom from a species, that is oxidation, that is also reducing agent. And losing of electrons is oxidation and those species is reducing agent. And increase in oxidation number is oxidation, and those species that get its oxidation number increase, that is reducing agent. So like that you can say the concepts of oxidizing agent also. Let us calculate the oxidation number of atoms in different species or different compounds and ions. So for that you need to know oxidation number of different elements in its compound state. What is the general trend? That should be known. So let us start with the first group. We know that the first group elements are lithium, sodium, potassium, rubidium, cesium and francium. So I am saying that elements lithium, sodium, potassium, rubidium, cesium and francium. And the thing is that is having +1 oxidation state in its compound state, not in elemental form. So you should think that in elemental form all have 0 oxidation state. In compound form, first group elements have oxidation state +1, second group elements have oxidation state +2, D block elements normally have +2 oxidation state, but variations is there. F block elements normally have +3 oxidation state, there are also variations. 13th group elements generally have +3 oxidation state. 14th group elements have +4 oxidation, generally it is +4, and there are also some variations. +4 oxidation state. 15th group have -3 oxidation state. 16th group have -2 oxidation state. 17th group -1 oxidation state. And there is variations for these all. So let us consider some of the examples. H2O, can you calculate the oxidation number of oxygen here? Yes, we know that hydrogen +1 oxidation state into 2 plus oxygen is considered as X, and that is equal to, this is a neutral compound, so let's calculate that with 0. So 2 plus X is equal to 0, X is equal to -2. What is the oxidation state of oxygen here? -2. So let us consider another example. So oxygen have one -2 oxidation state because that is at 16th group. Let us consider another example, that is H2O2. We know that hydrogen peroxide is there. Can you calculate the oxidation state of oxygen there? Yes. Yes, we can calculate that one. 1 into 2, that is +1 into 2 for hydrogen, plus 2x for oxygen is equal to 0. Is it? Let us consider this one. 2 plus 2x is equal to 0. Then 2x is equal to -2. X is equal to -2 divided by 2, that is equal to -1. So oxygen in hydrogen peroxide have -1 oxidation state. So oxygen have -1 oxidation state also. So that's a variation. Let us consider another example, that is KO2. So let's calculate the oxidation state of oxygen here. +1 for potassium into 1 plus 2x is equal to 0. 2x is equal to -1 and x is equal to -1 by 2. That is equal to -half. Oxygen have -half state also. So oxygen have different oxidation state, -1, -2 and -half. So in its monooxide, oxygen is in -2 state, peroxide that is in -1 state, and in superoxide, just like KO2, that is in -half state. And one more thing is there, OF2 is there, oxygen difluoride. Let us calculate the oxidation state of oxygen here. X plus -1 for fluorine into 2 is equal to 0. So we get X is equal to +2. Is it? So oxygen have +2 state also. So that's a variety in oxygen. So let us consider some of the examples for this calculation. Can you calculate the oxidation state of sulfur in H2SO4? H2SO4, what is the oxidation state of sulfur? Let us try. +1 for hydrogen into 2 plus X plus oxygen -2, 16th group element, into 4, that is equal to 0 because that is a neutral compound. So 2 plus X -8 is equal to 0. Then X -6 is equal to 0. X is equal to +6. So sulfur is in its +6 state. That is the oxidation state of sulfur here. Let us consider another example. Can you calculate the oxidation state of chromium in Cr2O7 2-? chromium. Can you calculate the oxidation state of chromium here? Let us calculate the oxidation state of chromium like this. 2 into X. X is the number of oxidation state in chromium. So that should be calculated here. Minus 2 for oxygen. How many oxygen is there? 7. That is equal to minus 2. Why here minus 2? Because that is not neutral. That have a charge that is minus 2. So 2x minus 14 is equal to minus 2. 2x is equal to minus 2 plus 14, that is equal to plus 12. X is equal to 12 by 2, that is equal to plus 6. So chromium is in its plus 6 state here. Like that, you can calculate the oxidation state of any atom in a compound. Let's take another example, that is C3O2. Can you calculate the oxidation state of carbon here? Yeah, just you try that one. That is just 3x plus minus 2 into 2 is equal to 0. Like that you can calculate the oxidation state of carbon, is it? But that is wrong, because this oxidation state is a fraction, but you should consider the state of carbon in this compound. Then only you can calculate the actual oxidation state of different carbon atoms in this compound. That is the actual oxidation state. So let us consider the bonding. C double bond, C double bond, C double bond O. Here also double bond O. This is the state of different atoms in this compound. So we cannot calculate the actual oxidation state of these all atoms if you consider that equation. So let us consider this structure for this type of compounds. So we know that this carbon is attached to this oxygen. So oxygen is minus 2 oxidation state, and hence that have plus 2 oxidation state. Here this carbon is attached to 2 other carbons. There is no oxidation, so that is 0 state. And this carbon is attached to this oxygen, minus 2 state for this oxygen, and plus 2 oxidation state for this carbon. So this is the order: minus 2 oxygen, then plus 2 carbon, 0 carbon, plus 2 carbon, and minus 2 carbon. Like that, in different compound like this, you should try the oxidation state of different elements. The paradox is there, so you should study the different oxidation state of elements in this type of compounds. That is different from the normal oxidation state calculation. Next, Stokes notation. So this is a representation of molecules, that is the oxidation state of a metal is placed in square bracket adjacent to that metal. Let us consider FeCl3, that is ferric chloride. We can write its oxidation state, that is, what is its oxidation state? That is plus 3. It can be written like this: Fe3Cl3, or ferric bracket 3 chloride. This is called Stokes notation. Like that, you can write the oxidation state of metal in bracket adjacent to that metal. This is called Stokes notation. Let us move on to some different types of redox reaction. Let us move on to types of redox reaction. There is different type of redox reactions. The first one, that is combination reaction. Next one, decomposition reaction. The next type of redox reaction is displacement reaction. Displacement. The next type is disproportionation reaction. These are the different types of redox reactions. Let us take some of the examples for these all redox reactions. Let us begin with decomposition reaction. So what do you mean by decomposition? Yes, we can study that from its title also. That is, if you have a compound AB, then if it decomposes, that is converted to A plus B. That is decomposition reaction. For example, water can be decomposed to hydrogen and oxygen. This is a redox reaction because here in water, hydrogen plus 1 state, oxygen minus 2 state, oxygen -2 state. So this +1 converted to 0 and -2 also converted to 0. So here is decrease in oxidation number, here is increase in oxidation number. This is oxidation, this is reduction. So this is a redox reaction and is a decomposition reaction. Let us consider combination reaction. This is combination reaction, that is nothing but its type is A plus B gives AB. That means two reactants combined to form only one product. That is combination type. For example, carbon plus oxygen gives carbon dioxide. Here carbon get oxidized and oxygen get reduced. This is oxidation, this is reduction. This is a redox reaction. Moreover, that is a combination reaction. Let us consider displacement reaction. Displacement is nothing but displacement of one element by other during a redox reaction. For example, XY react with Z to form XZ and Y. This is a displacement reaction. Here Y is displaced by Z. So these are of different types. That is, first one, metal displacement. More reactive metal can displace other metal from its compound. For example, zinc plus copper sulfate gives zinc sulfate plus copper. Look here. Actually, zinc is more reactive than copper. So copper is in +2 oxidation state, zinc 0 state. Here, zinc can replace copper from its solution if they are in contact. So zinc 2 plus and copper 0. Zinc get oxidized and copper get reduced. This is a redox reaction and this is a displacement reaction, and moreover this is metal displacement. Let us consider another thing of this reaction, that is, we can consider metal displacement. You can take copper sulfate solution here. Simply you can take copper sulfate here, that is bluish color, and you can place a zinc rod here inside. Zinc rod. What happens? That zinc rod can replace this zinc rod. This can replace copper sulfate like this. Zinc plus copper sulfate gives zinc sulfate plus copper. So bluish color is converted to just colorless. Here I am coloring that with water. So we get zinc sulfate. This is the reaction. So this is a replacement reaction, competitive displacement reaction. If you place another one, that is silver nitrate solution, and you place copper inside that. If you have copper inside, then you place copper inside that, then what happens? That is converted to blue. That solution can be converted to blue. Is it? How that converted to blue? That is copper replaced zinc. This is the reaction, that is copper plus silver nitrate gives CuNO3 twice, copper nitrate plus silver. So let us conclude, zinc can replace copper and copper can replace silver. Let us consider the metallic order here. Which one is more reactive? That is zinc. And next comes copper, next comes silver. So this is the order of reactivity of metals. So more reactive metal can replace less reactive metal from its solution. Let us consider another displacement, that is metal non-metal displacement. Metal can displace non-metal from its solution. So for example, let us take one example, that is sodium plus water. What happens? That gives NaOH plus hydrogen gas. What is the reaction? We know that in water H plus and OH minus is there, HOH. So here this hydrogen replaced by sodium and we get sodium hydroxide. So a metal replaced a non-metal hydrogen from this. This is called metal non-metal displacement. And let us consider another example, which is that non-metal displacement. Let's write the heading, that is non-metal can replace another less reactive non-metal. So that is called non-metal displacement. Let us take one example, fluorine plus water. What may be the reaction? HF plus oxygen. So here fluorine replaced oxygen from water. That is, more reactive fluorine replaced less reactive oxygen from its hydride. This is non-metal displacement. Let us move on to the next type of redox reaction, that is nothing, disproportionation reaction. Disproportionation reaction is nothing but an oxidation reaction and reduction reaction takes place in same species. Let's look this one. H2O2 gives H2O plus O2. So here oxygen is in its -1 state. We can calculate the oxidation state of oxygen in peroxides, that is -1. And here monoxide -2 state and here 0 state. There is 2 oxygen at product side. So this oxygen reduced and this oxygen oxidized. So this is an example for disproportionation reaction. That is, in a redox reaction, the same species get oxidized and reduced, then that reaction is called disproportionation reaction. Next, balancing redox reactions. So if you have a redox reaction, then you can balance that redox reaction by different strategies. The main 2 strategies are, the first one, oxidation number method. Oxidation number method can be used for balancing a redox equation. The next one, that is half reaction method. So let us discuss these 2 methods. What are the steps in this method? So you should analyze whether the reaction is acidic or basic medium reaction. So let us begin with the oxidation number method. Let us take this example, that is potassium dichromate react with sulfite ion, that is Cr2O7 2- react with sodium sulfite, that is SO3 2-, in acidic medium gives chromium 3+ ion and sulfate ion. This is the skeleton ionic equation. You should write the skeleton ionic equation first for balancing this redox equation by means of this oxidation number method. So this is the first step, skeleton ionic equation. And you should know that this is in acidic medium. So this is acid medium reaction. So let us move to the next step, that is assign oxidation numbers. That is the second step. You should assign the oxidation number. That is the second step. This is the first step. That is skeleton ionic equation. Then assign oxidation numbers. So you should calculate the oxidation number of Cr2O7 2- here. 2x plus -2 into 7 is equal to -2. Then 2x minus 14 is equal to -2. Then 2x is equal to -2 plus 14, that is equal to plus 12. X is equal to 12 by 2, that is equal to 6. So 6 is the oxidation number of chromium here. Sulfur, we can calculate the oxidation number of sulfur here. X plus -6 is equal to -2, that is -2 into 3. So x is equal to -2 plus 6, that is equal to plus 4. This is the oxidation number of sulfur. And here chromium 3+ state, here x plus -2 into 4 is equal to -2. X -8 is equal to -2. X is equal to -2 plus 8, that is equal to 6. So chromium 6 oxidation state, sulfur +4 oxidation state, and other sulfur that is +6 oxidation state. So assign oxidation numbers of these atoms, that is Cr2O7 2- plus SO3 2- gives Cr3 plus SO4 2-. Oxidation states, these are the oxidation states: 6 + 6 + 4, here +3 and +6. So that is the second step. Next one, third step, that is find the increase and decrease in oxidation numbers and make them equal. Here there is an increase in oxidation number from +4 to +6, and there is a decrease in oxidation number from +6 to +3. Is it? So let us calculate the increase and decrease. How many increase here? That is 2 increase. And how many decrease here? 3 decrease. But the thing is, here 2 chromium is here 2 chromium is there, and you should write 2 here to balance the chromium. So 3 into 2, there is 6 decrease of oxidation state for chromium and 2 increase for sulfur. So during reduction there is 6 decrease, but during oxidation there is 2 increase. So that should be balanced by cross multiplying these units. That is, 6 should be multiplied with this sulfur, and this 2 should be multiplied with this chromium. That is the next step. So let us consider the next step. So we can multiply 6 with sulfur. So the next step, step 3. So this is the step. That is, 2 should be multiplied with this chromium. 2 Cr2O7 2- plus 6 SO3 2- gives 4 Cr3 plus 6 SO4 2-. So the decrease in oxidation number, that is 6 multiplied with sulfur, and increase in oxidation number 2 multiplied with this chromium. So the next step is that let us count the net ionic charge. So ionic charge is the next step. Counting ionic charge and balance that ionic charge. Here 2 into -2. How many charges? 4 minus charges. Here 6 into -2, that is 12 minus charges. Here 4 into 3, that is 12 plus charges. Here 6 into 2 minus, that is 12 minus charges. So let us balance this one. Here 12 plus and 12 minus. Balanced. And here 4 minus and 12 minus, that is 16 minus here in left hand side. Is it? 16 minus excess. So let us balance that 16 minus by adding acid, that is H plus ions. So let us add 16 H plus, that is 16 plus at the left hand side. So we get the equation 2 Cr2O7 2- plus 6 SO3 2- plus 16 H plus gives 4 Cr3 plus 6 SO4 2-. And the final step, to balance this 16H plus, you can add water to the right side. So you can add how many water? For balancing 16H plus, you can add 8 water at the right side. So this is the balanced equation. So your steps are: first skeleton ionic equation, then assign oxidation numbers, then count the increase and decrease in oxidation numbers, make them equal by cross multiplying their units, and then find the total net ionic charge and balance that net ionic charge by using H plus ions if that is in acidic medium, and finally balance the excess H plus by adding water. If the reaction is in basic medium, instead of H plus you can add OH minus. So your steps are, that is in basic medium. So first write the skeleton ionic equation, next assign oxidation numbers, then count the increase and decrease in oxidation number of all species, then make them equal by cross multiplying the units of oxidation and reduction, then count the net ionic charge and balance that by using OH minus since that is in basic medium, and add water to balance the excess hydrogen. One more thing you should remember is that if you can simplify further this equation, you just simplify that one. Here 2, 6, 16, 4, 6, 8. So you can simplify that by dividing 2 in common. So you get Cr2O72 minus, 3 SO32 minus, 8H plus, 2 Cr3 plus, 3 SO42 minus, and 4 H2O. That is the final equation. Let us move on to the next method, that is half reaction method. Half reaction method. So in this method, the strategy is different. This method is otherwise called as ion electron method. So these are the steps. The first one, that is you should write the skeleton ionic equation. So skeleton ionic equation is the first step. Then you should separate oxidation and reduction in separate half. So you should write oxidation and reduction in separate half, and then balance atoms other than oxygen. So balance atoms other than oxygen, that is the next step. So you should follow these steps. Then fourth one, balance oxygen by adding water. So you should balance oxygen by adding water. Next one, balance excess H plus, that is hydrogen, by adding what? That is H plus ions at the opposite end. Next step, balance net ionic charge of the two reactions by adding electrons. So this is the next step. Then the final one, balance electrons in two reactions. Balance electrons. And finally, you should add these oxidation and reduction steps. This is in acidic medium. So you can balance the basic medium reaction also by this method. For that, after this step, that is the fifth step is here. After this fifth step, so after only this one, that is after fifth step, you can follow one more step, that is add equal number of OH minus ions at both the end of the reaction. You should add 4 OH minus at left side and right side of that reaction in basic medium. So this is the strategy that is used to balance ionic equation in half reaction method. In these two methods, we get the same results. So you should try to balance the ionic equations by means of this half reaction method in acidic as well as basic medium. Just try more reactions. This all about redox reactions.